They contain combination of tungsten, chromium, vanadium, molybdenum and cobalt. It can take heavy cuts, withstand shocks and maintain sharp cutting edge under a red heat. It means that the material is having sufficient red hot properties, means at elevated temperatures it is able to maintain its edges, and secondly it is also having sufficient toughness. Generally it is of two types. One is general purpose. General purpose is known as molybdenum grade or group M, and tungsten base, which is known as group T. Cobalt is added if more heatness is desired. We can skip this portion since the time is not available. Let us come to the geometry of a single point cutting tool, which is very important. A single point cutting tool look like this. If we have a look at the tool which we use on the lathe machine, it will look like this. And take my word, a single point cutting tool is having all the angles and all the geometries which will also be available or which is to be given on the each cutting edge of the multi point cutting tool also. To elaborate this further, let us have a look at the main parts or main portions or main angles or parameters, whatever we like to call it, we may call it, of a single point cutting tool. The portion of the cutting tool or the main body of the cutting tool out of which it is made is known as shank. The main body of the tool, it is a part of the tool which is gripped in the tool holder. So, in this portion we can say that this is the shank which is held or which is fastened in the tool post. The face is the top face of the tool between shank and the point of the tool. Chip flows along this surface. So, this particular portion is known as a face, since chips flow over this surface. The flank, as I explained in the earlier figure, is the portion of the tool which faces the work. So, this is the flank. It is surface adjoining to and below the cutting edge when the tool lies in the horizontal position. The point, this particular point is known as the point, this which I am encircling, this is point. This is wedge shaped portion where face and flank of the tool meets. The base is the bearing surface of the tool onto which it is held in a tool holder. The lower portion of this whole tool is known as base. The nose radius is the radius given to this particular edge. This particular point is known as the nose radius. Cutting tip which carries a sharp cutting point, nose provided with radius to enable greater strength, increased tool life and surface life. Typically, the value is 0.4 mm to 1.6 mm. If we see the three-dimensional figure or orthographic projection of a cutting tool, it will look like this. This is the side view. This particular thing is the top view, and this is the front view or end view, as we sometimes call it. In this case, the most significant terms in the geometry of a cutting tool are relief or clearance angle, which is side relief, end relief, rake angle, back rake angle and side rake angle, the cutting edge angle, side cutting edge angle and the end cutting edge angle, and the nose radius. Let us see these one by one. The cutting tool terms: a relief or clearance angle, ground on the edge and side face of tool to prevent it from rubbing onto the workpiece. It enables only the cutting edge to touch the workpiece. Side relief angle, angle ground directly below the cutting edge on the flank of the tool is known as the side relief angle. End relief angle, angle ground from the nose of the tool is known as end relief angle. If we look at the picture, then we can see that this angle, the angle which has been given to this edge, which was otherwise horizontal or perfectly horizontal, has been intentionally given some angle or some tapered angle in this direction. So, that this particular face is now having some sort of relief, and it is not it is given to sharpen this edge. If that side arc angle is lesser, then the sharpness of this edge will not be sufficient, and the machining or the rate of machining which will lower than that which is having a higher sharp thickness. The other angle of the side relief angle is the angle given to this edge. This particular angle is essentially known as side relief or side clearance angle. The angle given to this end is known as end relief angle. If we look at the terminology again, then we can say that whichever angle is given to the face, angle given to the face is known as side rake, and the angle given to this portion or this flank, this is known as side relief, and the angle given to this end is known as end relief angle. The main purpose of this relief angles is to prevent the tool from rubbing onto the workpiece, which will unnecessarily increase the friction, which not only increases the overall requirement of power to carry out the machining, but also decreases the finishing of the workpiece, because in case the tool edge is rubbing onto the already finished workpiece, then it will say decrease the finishing of that particular piece. The cutting edge angle is ground on a tool, so that it can be mounted in the correct position for various machining operations. That there are two cutting edge angles mainly. One is side cutting edge angle, and this is the side cutting edge angle, the angle which is over here. This is known as side cutting edge angle, and the end cutting edge angle. End cutting edge angle has been given to the end, as we have seen in the other slide. As this end relief was given to the end, similarly this end cutting edge angle is also the angle which has been given to this end. So, this particular angle is the end cutting edge angle. The side cut, if we see the significance and the other things related to the side cutting edge angle. So, we read out the slide. It allows flank of the tool to approach the workpiece first, then it spreads the material over a greater distance onto the cutting edge, thereby thinning out the chips. It is approximately 15 degree. For most lathe operations, it is normally 15 degree. And cutting edge angle allows the cutting tool to machine closer to the workpiece during turning operation, and is usually from 20 to 30 degree. Other angles which are very important are rake angles. Again, there are two rake angles. One is back rake angle and the other one is side rake angle. If we look onto these two pictures, then we can see here that this particular angle is the side rake angle, and this is the side relief angle. And similarly, here we can say that it is the back rake angle which has been given to the face, and this is the end relief angle. The rake angles are ground onto the tool to provide a smooth flow of the chips over the tool, so as to move it away from the workpiece. Back rake angle is ground onto the face of the tool. It influences the angle at which chips leaves the nose of the tool. It is generally kept 8 to 10 degrees in case of turning operations. Side relief angle is ground on the tool face away from the cutting edge. It influences the angle at which the chip leaves the workpiece. A lathe tool has 14 degree as side rake angle normally. This slide shows the importance of side rake angle. We have shown two pictures here, which is showing a turning operation going on with a positive rake angle and a negative rake angle. A positive rake angle is the most commonly given rake angle and is normally used in the high speed steel tools that we used in our workshops normally, and a negative rake angle is normally given to the tools which are not that tougher, such as boron nitride tools or CNB tools, which are having lesser toughness, but that are having sufficient hardness, so that the cutting edge is fragile, and in case we give it an angle like this, it may break off. To avoid this breaking off, we give a negative rake angle to the workpiece, as can also be seen that in case of a positive rake angle, the force of cutting is coming in this way. We can also see that the chips are following in this direction, and the forces are coming, the net shell of forces are coming in this direction, and so that in case this particular material out of which the cutting tool has been made is not that strong in the terms of toughness, then it may cause this force may cause the breaking away of this cutting edge or this particular edge of the tool. And but this particular problem can be solved using a negative rake angle, as we see here. In this case, by giving this negative rake angle to the cutting tool, the force direction of force cutting force has been diverted, so that now the cutting force is coming in this direction, and it will no longer be able to break off this chip or the break off the actual cutting edge, which is actually doing the cutting. So, that this is the significance why we are using a negative rake angle in case of a carbide tip tool, because they are not sufficiently tough so as to withstand this type of forces. So, by giving a negative rake angle, the forces coming on to that particular type of tool is made to be diverted in this direction, so that it no longer affects the overall the toughness of this particular tool. We can also read out here it should be large as possible to allow chips to escape. Actually, it should be larger. We can also, from the common sense, we can also see that if the rake angle is larger, then this edge, which is actual cutting edge, this particular edge will be sharper, and hence the chips will be easier to flow onto this particular edge. But in case we go on increasing this angle, then although the sharpness of the tool is increasing and the flow of chips over this rake face is also been made easier, but the overall strength or the toughness of this edge is going down, and ultimately it may reach a position where the breaking off or the breaking away of the tool may take place. Amount is determined by the type and grade of the cutting tool, the type of material which is being cut, and the feed for revolution. By saying this, we are trying to say that if we I have already quoted that in case the material is made out of high speed steel which is having sufficient toughness, then we can give a rake angle which is a positive one, and it can also be given a greater amount of rake angle without assuming that it will not break away while the machining is being going on. But in case we are using a carbide tip tool, since these tools are very fragile, we will need to give it a negative rake angle so as to prevent its breaking off. And similarly, it will also depend upon the type of material which is being cut. Some materials try to stick onto the negative rake angle, because they try to get attached to the material of the cutting tool, and there are certain other parameters also which determines the which type of rake angle which we have to give depending upon the material which is to be actually machined. The feed per revolution is also important, because in case the feed is too much, then the rake angle has to be slightly lesser, because the force of cutting which will be coming onto the cutting edge, which will be much greater in that case. Angle of keenness is formed by the side rake and the side clearance. This particular angle is known as the angle of keenness, and as have been already explained again and again, in case we go on decreasing this angle of keenness, then the cutting edge will become very sharp, but at the same time it will become fragile and will be bound to break off in case some sudden loads are coming onto the stage. We also determine this rake angle depending upon the load which has to be come onto the cutting tool, in the term of whether it is a continuous load or it is an intermittent load. Suppose we are to machine a gear flank, whereby the load which will be coming on to this workpiece will not be continuous, but will be intermittent, then it will give it an effect just like the striking of a hammer, and in case the side rake angle in this case is much more, then it will result in the immediate breaking out of this particular tip. And so, depending upon the geometry of the cutting of the workpiece also, we will depend on whether the side rake angle should be greater, positive, negative, or flat. Back rake angle, we can see here. Here the back rake angle is in this direction, the back rake angle is positive, and here the back rake angle is negative. In case the back rake angle is positive, the pressure which is coming on to this particular chip is coming in this direction, and once we made this rake angle as negative, then the pressure which will be coming on to the chip will be in this direction. We can see here, since the pressure is coming this way, it is causing a pressure onto this cutting edge, and as a result of this pressure the tool tip may break off. But since by giving a negative rake angle, we have changed the direction of the force, then as a result the force is now coming on to the shank of this tool, and as a result it will no longer causing any threat to the breaking off or the wearing away of this cutting edge. So, in case of a fragile tool just like a carbide tip tool, we need to give a rake angle which is negative as compared to the conventional type of tools such as HSS tools, where the rake angle is always positive. If we formally say what is a rake angle, then a rake angle is the angle formed between top face of tool and the top of the tool shank is known as a rake angle. It is positive. In this case, the first figure shows that it is a positive rake angle, as is given to most of the cutting tools that are commonly used, such as a high speed steel cutting tool. Here the top face is sloped downwards away from the point, it is downward away from the point, but in this case the pressure is coming in this direction, and in case the material is not sufficiently tough, it will lead to breaking out of this edge. And it is negative, if it is negative as has been shown over here, the top face is sloped upward away from the point, as can be seen here, and in this case we can see that the direction of force has been changed in such a way that the pressure is going onto the shank, and in some cases it is kept 0, and in that case it is said to be neutral, and the direction of force in that case will be vertically downwards, and in that case also the chances of breaking away or the threat of breaking away of the tool tip because of the excessive pressure are very negligible. Rake angle is small to medium rake angle causes high compression, high tool forces, high friction and results in thick, high deformed hot chips. A negative rake angle, typically tool materials which utilizes negative rake angle are carbide tip tools, diamonds, ceramics. All these three type of category of tools, they are very fragile, although they are very strong in terms of the compressive strength, but they are not in a position to withstand the intermittent loads, or in other words we can say that the toughness of these materials is not up to the mark, and as a result to avoid the breaking away of this tool tip, we generally give these type of tools a negative rake angle. These materials tend to be much more brittle than high speed steel, but they hold superior hardness at high temperature. The negative rake angle transfer the cutting forces to a tool which help to provide added support to the cutting edge. We have explained all these things through these two figures already. We can again see, as has been written in this statement, that in case we give a positive rake angle to this type of materials, then the force which is coming onto this direction may cause the breaking away of this tool tip, which in case it is made out of a material which is not that tough, just like diamond or ceramic or even the carbide tip tools. But by doing this arrangement or by making the this tip to slope in this direction, although the sharpness of this tool has been decreased a bit, but the strength and the ability to withstand the pressure and the toughness of the tool have been increased, and as a result now the tool will be able to withstand the intermittent loads as well as the very hard or the very high speed loads without any threat of breaking away. Tool angle applications. Factors to be considered for tool angles are the hardness of the metal, the type of cutting operation which are to be carried out, material and shape of the cutting tool, the strength of the cutting edge. These are some of the things that are to be taken care of while considering the various angles that are to be given to the cutting tools. The hardness of the metal that has to be machined is also very important, because the material that has to be machined, in case it is harder than the than the normal material, then the cutting force which will be coming on to the tool which will be much more, and also we will be forced to use the tool material which is much harder than the normal tool material, and in this case the forces that will be coming on to the cutting tip will be much more, and accordingly we will normally prefer to give it a negative rake angle or negative cutting edge angle, so as to avoid any breaking away of the tool tips. The type of cutting operation as explained, in case it is a continuous operation, the forces that are coming on to the tool are of continuous nature, hence the toughness is not an issue, and in case it is a intermittent operation where the cutting is not continuous and the cutting is coming in as intermittent blows, as in case of a milling machine, the toughness of the material should be much more, and if the material is not that tough, then the angles have to be adjusted in such a manner that the cutting edges are prevented from breaking by giving these type of angles. The material and the shape of the cutting tools again is important. Material I have already explained, and the shape of the cutting tool, we can see that different type of cutting tools require different type of cutting shapes that are to be given to the cutting tools, because in case of every cutting tool, since the shape of the cutting tool also determines the shape which will finally be given to the workpiece. So, depending upon whether the shape of the cutting tool give us opportunity to give it a negative rake angle or a positive rake angle, we will also decide the type of angles which are to be given to the cutting tools. The strength of the cutting edge, whether it is a stronger edge or a weaker edge, will also determine whether we are going to give at a negative rake angle and a negative side cutting edge angle, or a positive side cutting edge angle, as have been explained in details in the previous slides. Now, since the time is running out, I will not deliberate much on the other issues, and we will keep the other things such as the basics of cutting and the cutting process, actually how it is taking place, and how these angles that we have learned in the basics play a crucial role while calculating the cutting forces, and how the machining speed and the metal removal rates are calculated. I will be taking these topics in my next lecture, probably in the next session, because now the session is going to be over within a few days. And I again thank you for giving me a patient hearing, and give you try to say best of luck for your exams. Thank you.